this is Ms. Heaney. This lesson starts on page 92, so please turn to page 92. You'll see this up at the top. This lesson is about solving equations that have more than one variable and solving for one specific variable in that equation. Before this lesson, you should have finished the lesson on solving two-step equations and finished the lesson on solving multi-step equations and done the classwork for both of those. So make sure you have that done first. Alright, so if you're done with two-step and multi-step equations, let's get down to solving for a variable. In this problem, there are two variables here, not only x, but also a. In fact, a is acting like the coefficient for x. It's the number being multiplied in front of x. So if we're solving for x here, we're going to have to deal with that a. Now, the steps are actually exactly the same as just a regular two-step equation. We're just going to have to take into account that we don't know what a is, but we can still solve this equation for x. So let's try it. Well, first thing to do is to get rid of this plus 3. And we do that the same way we would normally do. We subtract 3 from both sides. So that's simple enough. On the left side, we're left with a times x. On the right side, 5 minus 3 simplifies to 2. So far, so good. The next part is the tricky part. To get x by itself, we have to divide by this coefficient, a. Well, to do that, we can divide both sides by a. The a cancels with the a in front of x. That part is fine. We get x by itself. That's all good. The weird part is on the right side, 2 divided by a. A is a variable. It could be any number. We have no idea what number a is. So we can't really simplify this or evaluate it. We have to just say, all right, 2 over a is just the answer. There's not much more we can do there. So in these problems, unlike the last problems we've done, we're not going to get x equals some number as our answer. That's just not going to happen. Instead, we're going to get x equals some expression that has another variable in it. And that's okay. Let's try some more problems like this. Number 1, negative ax plus 1 equals negative this, like a regular equation. First thing I want to do is subtract 1 from both sides to cancel the plus 1. That leaves me with negative ax equals negative 80 and negative 1 combined to negative 81. The next step is the weird step. We want to get x by itself, so we have to divide by that coefficient. Our last step is going to be to divide by the coefficient, which is negative a. Negative a and negative a cancel. That part is fine. We get x by itself. So far, so good. We have negative 81 divided by negative a. We're not going to be able to really simplify all of this. The one thing that we can simplify is I do know that negative divided by negative is positive, so that's something. We know that we're going to have a positive result. But the 81 over a part, we can't really simplify any further. So that is my answer. This is still an equation, by the way. I have x equals some expression that's not simplified. But that's okay. This is as far as we can go without knowing what the value of a is. Let's try number 2, ax minus 5 equals 10. I want to leave the coefficient as my last step, so I'll deal with the minus 5 first. I'll add 5 to both sides. Cancel minus 5. I end up with ax equals 10 plus 5 is 15. And now I'll have to get x by itself by dividing both sides by a. A cancel. I end up with x equals 15 divided by a, whatever that is. That's as far as we can simplify. Number 3 is a little bit different because we're not multiplying x by a, we're dividing x by a. So I'm going to have to do the opposite of dividing by a, which is multiplying by a. So times a, that cancels. We end up with x equals 10 times a. I'll just write as 10a. And x is by itself. Number 4, 2xa plus 4 equals 8. So x is not only being multiplied by a, it's also being multiplied by 2. So we'll have to deal with all of that when we get there. But before we do, let's deal with the 4. Minus 4 on both sides. That cancels. We get 2ax equals 8 minus 4 is 4. All right, we have two things being multiplied by x. So I could divide both sides by 2 and then divide both sides by a. That would be perfectly fine to do that in 2 separate steps. I could also do it all in one step. I could divide both sides by 2a just all in one step. So I'm going to show you that. If I divide both sides by 2a cancels. I get x equals 4 over 2a. But that can be simplified. 4 and 2, I can divide those each by 2 and get 2 and 1. So that simplifies to 2 in the numerator, 1a in the denominator. That's just a. So there's my answer. So why would we use this? Why would we ever have equations where there's more than one variable and we want to solve for one of those variables? Well, there's 2 places where this comes up the most often. It comes up in different math formulas, which we'll see on page 94. It also comes up in equations for graphing lines, and we're going to see that on page 93. So let's take a look at page 93. Writing equations in slope-intercept form. Remember this from last unit? Slope-intercept form is another way of saying this y equals mx plus b format. Y equals mx plus b was our favorite format for graphing an equation, but we didn't always have equations in that format to start with. So what do we do about that? One thing that you could do is you could put an equation in this format by getting y by itself. In other words, solving for the variable y. That's what we're going to do right now. So just a reminder, a little hint here. Recall, to solve for a variable, we need to isolate the variable on one side of the equation. If the equation has 2 variables, we can solve for one of them. In this case, we're going to want to solve for y. So here's an example. This equation is not in y equals mx plus b format, but it does have a y, it does have an x. Let's say we wanted to put it into that y equals mx plus b slope-intercept form. So we're going to solve this equation for y. We're going to begin with the original formula, the original equation. We're going to get y by itself. So I'll leave the coefficient of -4 for the last step. I'll first start by adding 8 to both sides. Plus 8 plus 8. That cancels. I end up with -4y on the left side. On the right side, I have 12x plus 8. These are not like terms. This one has x, this one doesn't. But that's okay. If I just write it as 12x plus 8, that's perfectly fine to leave it that way. And in fact, this is starting to look like the mx plus b format that we're so fond of. But y is not entirely by itself. It's not in y equals mx plus b format yet because y is not isolated. So next step is to divide both sides by -4. So I'm dividing that side by -4, which will cancel. I also need to divide everything on the right side by -4. Let's see what we get. Y is by itself. That's good. That's what we want. 12x divided by -4. I know 12 divided by -4 is -3. So that's -3x. Also, 8 divided by -4 8 divided by negative 4 is negative 2. And look at my result. I have an equation in y equals mx plus b format. I can see that my y-intercept is negative 2. I can see my slope is negative 3. If I wanted to graph this equation, I would be able to do so pretty easily. Let's try some more problems here. Problems 1, 2, 3, 4, and 5 are all in the same format. This is called standard form. This is where both the x and y term are on the left side of the equation. And we don't want that. We want y equals mx plus b. So we're going to have to solve these equations for y by doing a couple of steps. First step is I want to get rid of the x term on the left-hand side. So in this case, I'm going to subtract x from both sides. Minus x, those cancel. On the left side, I'm left over with negative 2y. On the right side, I have negative 14 minus x. A couple things about this. First of all, these aren't like terms, so we're not actually going to combine them. We'll just write them in the same line. The second thing is if I truly want this in y equals mx plus b format, it would be nicer if the x term was listed first, then the other number. So I'm actually going to switch the order here. I'm going to write minus x minus 14. I don't have y by itself yet though. I need to divide both sides by negative 2. That will cancel and get y by itself. I need to divide the other side by negative 2. Let's see what I get. Y equals, all right, negative x divided by negative 2. First of all, negative divided by negative will be positive, so we're going to get something positive. Also, this is 1x divided by 2. 1 over 2 is 1/2, and I'll just put the x next to the 1/2, because that's the format that we're used to for slope times x. Then this part is a little bit easier. Negative 14 divided by negative 2 is positive 7. So there's my equation. Y equals 1/2 x plus 7. I know that my y-intercept would be 7. My slope would be 1/2. I'm good to go. Number 2 is very similar. 3x plus 5y equals 25. I'm going to do the same two steps. I'm going to get rid of the x term on the left-hand side. Then I'm going to divide by the coefficient. So we get rid of 3x by subtracting it from each side. Cancels. I end up with 5y on the left side. On the right side, I have 25 minus 3x. These are not like terms, so I will not actually combine them. I also have the number first and the x term following that. I don't want it in that order. I want it in more mx plus b order. So I'm going to list the x term first. So I'm going to list minus 3x first, and positive 25 can follow. My second step is to divide by the coefficient of y. I'm going to divide everything in this equation by 5. On the left side, the 5's cancel, and we get y by itself. On the right side, let me look at each of these two terms divided by 5. Negative 3 over 5 is negative 3/5 x. 25 divided by 5 is 5. And I have y equals my slope times x plus my y-intercept. And oftentimes you get this slope, that m number being a fraction, but that's okay. Slopes are often fractions, so don't worry about that. I'll do one more of these with you. 3x minus y equals 8. I'll start off by getting rid of the x term on the left side, so I'll subtract 3x, subtract 3x. That cancels. I end up with negative y equals, I'll list the x term first like I did in the previous two, so that's negative 3x, positive 8. And y looks almost by itself, but not quite. I have this negative y. Negative y is the same as negative 1y, so I'm going to divide everything in this equation by negative 1, negative 1. That cancels the negative in front of the y. I get positive y equals negative 3 divided by negative 1 is positive 3. 8 divided by negative 1 is negative 8. So I get y equals 3x minus 8. 4 and 5 are very, very similar to the three problems that I just did. So go ahead and pause the video right here. You're going to try problems 4 and 5 on your own. When you are done with those problems and think that you are ready to see the answers, go ahead and unpause the video and you can check your answers with mine. So go ahead and try those out. All right, are you ready to see my answers compared to your answers? I hope so. All right, so check out my answers for problems 4 and 5. All right, so problem 4, I subtracted 11x from both sides. I divided both sides by negative 7. Negative 11 divided by negative 7 is a fraction. Negative divided by negative is positive, so I got 11/7 x minus 5. Number 5, I subtracted 15x from both sides. I then divided both sides by negative 7. I end up with y equals positive 15/7x minus 7. If you didn't get the same answers as I did, look over my work, look over your work, see where the mistake might have occurred. Number 6, 7, and 8. These are not in standard form like problems 1 through 5. You might recognize this as being in point-slope form. We have our slope next to the equal sign. We have numbers next to x and y that represent the x-coordinate and y-coordinate of a point that this line goes through. So I know that, and it goes through the point positive 2, negative 4. But what if I don't like point-slope form? I want to put this in slope-intercept form, y equals mx plus b. I can do that by solving for y. Each of these three problems is going to have the same 2 steps. I'm going to first start by getting rid of these parentheses because y equals mx plus b does not have any parentheses, so I can do that by distributing that number. I also want to get y by itself, so I'll have to get rid of the number that's either added to y or subtracted from y. So those are going to be my 2 steps. I'll start with the distributive property. I'm going to distribute negative 3/2 times x. That's just negative 3/2 x. Yeah, it's a fraction, but that's okay. That's our slope. Slopes are usually fractions. I'm also going to multiply negative 3/2 times 2. Now this looks frightening at first, but we can figure this out. Negative times negative, first of all, will end up being positive. Also, 2 is the same as 2 over 1. This 2 and this 2 are going to cancel each other out, leaving us with 3 over 1, or just 3. That wasn't so bad. On the left side, we still have y plus 4. We haven't done anything with that yet. That will be our next step, though. Once we've distributed and gotten rid of the parentheses, we want to get y by itself. So to do that, I'm going to subtract 4 from both sides. So I'm going to subtract 4 from 3. Those will cancel. And I get y equals negative 3/2 x. Positive 3 minus 4 is minus 1. There's my equation in y equals mx plus b form. For number 7 and 8, I'm going to do the exact same 2 steps. I'm going to distribute the slope, and I'm going to get y by itself. So let's do that. I'm going to distribute negative 4 times x, negative 4 times 1. That comes out to negative 4x minus 4. I still have y minus 3 on the left side. I'm then going to get y by itself by adding 3 to both sides. Minus 3 plus 3 cancels. I end up with y equals negative 4x minus 4 plus 3 is minus 1. There's my answer. Go ahead and try number 8 on your own. So you can pause this video in order to try number 8. Remember, distributive property first, followed by getting y by itself. And unpause the video when you think you have your answer ready. All right, are you ready to check your answer with mine? Here we go. I got y equals negative 2x minus 3. I got that by distributing negative 2 through the parentheses. I then added 3 to both sides. I got y equals negative 2x minus 3. All right, so this demonstrates one area where solving for one of the two variables is useful when we're trying to put an equation into y equals mx plus b format. The other useful application of this is in using formulas. If you flip over to page 94, we're going to look at some formulas. Formulas are used often in math. Formulas are also used a lot in science, especially physics class. And formulas are often written in one way, but that's not always the most useful format of the formula. Sometimes you want to rearrange a formula to highlight one variable instead of another variable. So let's try it. We're going to look at formulas. We're going to look at how to use them and how to rewrite them in terms of another variable. So let's start with this formula. Use the formula area equals base times height to find the length of the missing base b for parallelograms with the given dimensions. All right. So number 1, we have a parallelogram with an area of 24, a height of 8. Well, I know base times height should be the area, so I need to figure out what number times 8 is equal to 24. Well, that number is 3. 3 times 8 is 24. Let's try number 2. The area is 105, the height is 15. So what number times 15 will be 105? Well, I don't know that off the top of my head, but I can also think about it. What is 105 divided by 15? That's the same thing. And this one actually comes out to 7. 15 times 7 is 105. Also, 105 divided by 15 is 7. So this is actually not the best formula to use if we're trying to figure out b. It would be a lot more helpful if that formula was in terms of b. So let's do that. I'm going to take this formula, a equals base times height, and I'm going to solve the formula for the base. So that means I need to get rid of this height. So I have base times height. To cancel the height, I would want to divide both sides by the height. End up with the base is equal to the area divided by the height. So all I have to do is divide these two numbers to get my answer. So let's think about this. 56 divided by the height of 4. Let's see, 40 divided by 4 is 10. 16 divided by 4 is 4. Number 4, 48 is the area, 12 is the height, 48 divided by 12 is 4. The area is 10, the height is 1. 10 divided by 1 is 10. The area is 18, the height is 2. 18 divided by 2 is 9. Now let's double check using our original formula that these actually make sense. So I'm going to check 4, 5, and 6. All right, base times height should be equal to the area. So base times height, 4 times 12 is equal to 48. Yes. Base times height, 10 times 1 equals the area of 10. Yes. Base times height, 9 times 2 equals the area. Yes. So what we're doing here is we're solving for one variable by just rearranging things within the equation. All right, so to solve for a variable, we need to isolate the variable to one side of the equation. Some possible steps that you might have to do. You might have to deal with parentheses, so you can do that by using distributive property, Or you could also multiply both sides by the reciprocal. You might need to combine like terms. You might need to add or subtract things from both sides of the equation. You might need to multiply or divide things on both sides of the equation. Let's see some examples. So here's an example using geometry. The area of a rectangle is area equals length times width. That's actually the same as base times height. Sometimes we just call it length times width, but it's the same thing. We're going to solve this equation for W. So if we want to get W by itself, start with the original equation. Right now, W is not by itself. We have L times W. Well, we can cancel multiplying by L by dividing by L on both sides. Those cancel on the right. On the right side, we get W by itself. On the left side, we have A divided by W, which we'll just leave as A over W. That's fine. There's our equation solved for W. Here's another example from geometry. The area of a triangle is 1/2 times base times height. Sometimes this is also written as base times height divided by 2. It's the same thing, but we'll use 1/2 times base times height for right now. We're going to solve for B, the base. We're going to begin with the original formula, the original equation. There's two things I need to get rid of. I need to get rid of 1/2. I need to get rid of the height. I'll start with 1/2. I can get rid of multiplying by 1/2 if I multiply both sides by 2. So on the left I have 2 times A, that's fine. On the right, 1/2 times 2 cancels. So this is another physics problem. If you're an electrician, you deal with Ohm's law quite a bit. Or if you're any sort of mechanical engineer, Ohm's law comes into play. So let's take a look. All right, example 6. Ohm's law states that the current through a conductor between 2 points is directly proportional to the potential difference across the 2 points. Okay, so we're talking about an electrical current here. If you don't understand that, that's okay. We have a formula. The formula is given by I equals V over R, where I is the current through the conductor, so the amount of electricity. V is the potential difference measured across the conductor, and R is the resistance of the conductor. Okay, well, the nice thing is all I really need to know is this formula, because I'm going to solve it for V. I'm going to begin with the original formula or equation. I want to get V by itself. I have V divided by R. I want to get rid of dividing by R, so I'm going to multiply both sides by R, because that's going to cancel that denominator. So on the right side, I get V by itself. Fabulous. On the right side, I have R times I. There's my equation.